Good evening. This is Doug Cook, your host for tonight. I'm the Education Events Coordinator for NOFA Mass, and thanks for joining us. Tonight we have Dave Jacke for Gardening Like a Forest, Applied Ecological Design for Homesteads. Healthy forests maintain, fertilize, and renew themselves. Forest gardens mimic natural forests while growing food, fuel, fiber, fodder, fertilizers, pharmaceuticals, and fun. We can meet our own needs and regenerate healthy ecosystems simultaneously. We'll explore forest gardening's vision and some underlying science, real-life examples, and useful perennial plants. Dave Jacke is a longtime ecological designer and author of Edible Forest Gardens. We couldn't do it without these sponsors here. With their support, we are able to bring you all these great events, and as well, we encourage you to say how much you love their support of NOFA Mass when you visit them and buy their amazing good things. We want to remember that we are inhabiting this land here. We're presenting, we are attending and hosting this workshop from land that was inhabited and managed prior to European colonization. We want to use this slide as a reminder of this land that we steward has a political and social justice context. Descendants of white colonists and white immigrants own most of the land in this country due to racist practices, beginning with broken treaties and extending through sharecropping and redlining to mortgage lending discrimination practices that are ongoing today. Please take a moment to consider the role that land ownership plays in the economic security, well-being, capacity for self-reliance, and political power of all people. And consider this in the context of who owns the land today and why. And with that, I believe we are ready to turn it over to Dave, who has a great presentation.
Thanks very much, Doug. Get my sharing going here. And okay, there we go. I do have handouts if you're interested that you can email me for those. My email address will be at the end of the presentation, and you can email me and I'll send out a bunch of stuff to you, which summarizes a lot what's going to be in my talk. My website, unfortunately, my ISP shut down without warning me, and I've not been able to get my website back up again yet. So that website is currently not available, but hopefully soon I'll be able to communicate with you through that again. So anyway, I would like you to imagine yourself in a forest where virtually everything around you is food. You've got an open canopy of trees that has gaps in the canopy. If you look among the branches, you can see fruits and nuts growing and ripening and swelling on the branches. In the gaps in the canopy, below the gaps in the canopy, there are shrubs, which also have berries ripening in the sun. On the ground, you have a diverse cover of plants, herbaceous, perennial, annual, biennial, all different kinds of plants, perennial vegetables, native edibles, ground covers for controlling weeds, plants that are attracting beneficial insects, all kinds of stuff. There's a jungle in there. And this image here is taken from one of the first modern Western forest gardens on the planet at Robert Hart's homestead in Shropshire, England. And you can see it looks very woodsy there, but kind of the paradox that's built into the name forest garden is that this looks like a forest, but it's actually a garden scale. It's only 40 by 80 feet in size. So you can get a very foresty habitat in a very small area. For me, the vision of forest gardening really comes down to this, which I consider to be the single most important sentence from Masanobu Fukuoka's classic book, The One Straw Revolution. The ultimate goal of farming is not the growing of crops, but the cultivation and perfection of human beings. So many of the issues that we face in the current era are really about who we think we are. And if we believe as human beings that we are isolated, separate individuals that are not part of a larger system, then we're never going to be able to garden or farm in anything like an ecosystem fashion. So the way we garden reflects the way we see the world, and we need to therefore shift the way we think if we're going to get out of this crisis that we've created for ourselves. So for me, the ultimate goal of forest gardening is not just growing food. I definitely like to eat. So I do want to grow the food, but I also want to cultivate and perfect new ways of seeing, thinking, being, and acting in the world. So we're trying to cultivate and perfect ourselves, and that is reflected in what we create outside of ourselves. So on a more practical level, a forest garden is a forest mimic. We're using the forest as a design metaphor. So what that means is we're gardening like the forest, not gardening necessarily in the forest. You can do a forest garden in existing woods. It's more challenging in a lot of ways, and we've done so much damage over so long to the healthy native ecosystems of this continent that we really need to be recreating those functions. And so I see forest gardening, or edible forest gardening, or medicinal forest gardening, or whatever kind of forest gardening we're doing, as a way to reestablish healthy ecosystem function. So we're consciously designing an ecosystem. At an even more basic level, an edible forest garden is a perennial polyculture of multi-purpose plants. A perennial is a plant that has a 3,000 to 3,000 year lifespan. A polyculture means you have many species in any given patch of ground, ideally 3 or more. And then multi-purpose means that each species has at least 3 uses or functions, including food, fuel, fiber, fodder, fertilizer, pharmaceuticals, and fun. And we could probably find some other F words to include in there. This is a photograph of a forest garden at 7,000 feet on the dry side of the Colorado Rockies. If they can do it there, then I'm sure we can do it here. Now that's early in that forest garden's life. The fruit trees are still pretty young. There's a lot of sun, so the species would change. You don't see, actually, I think there might be one apple tree somewhere in there, but those are mostly support plants in there, nitrogen fixers and stuff like that. But you know, that's one of the challenges too, is adapting to the shade, having a successional process with the growing conditions change over time, and growing useful products throughout that whole successional sequence. So, you know, we're talking primarily in this talk about edible forest gardens. So food uses are really a critical piece here. There's a bunch of different kinds of foods we can get out of a forest garden. You can get fruits, nuts, greens and shoots, roots, culinary and tea plants, and mushrooms. That fruit is a wild grape. There are a number of wild grapes that are quite tasty and quite edible from this region. Many of the cultivated grapes that we grow are selections or cultivars of those, or hybrids with European grape varieties. But the wild ones are often quite good, and I encourage you to go seek those out. And then if they are really good, then maybe, you know, start selecting it and propagating it and name it after your dog or your partner or whatever, and put it out in the trade, because we could use some more good grape varieties probably. All right, so the nuts there in the middle are butternuts, which are a native high protein, high oil nut. The butternut is a species that has been decimated by native and non-native pests and diseases over the last while. And it turns out that the native peoples of this region used to burn butternut groves, burn the ground under the butternut groves every 3rd year on a rotation. And the author who wrote that, Carl Davies, who sadly is no longer with us, he's a forester living in Northampton, Mass. But the research that he did indicated that they were doing that as a way to warm the air temperature. They would burn the ground in April before the leaves came out, but when the plants were flowering, the trees were flowering, because pollen grains will grow to fertilize the ovum of a female flower at a rate dependent on temperature. And if the ground is black because of the fire, then the air temperature will be warmer, and that way they would get more fruit. But of course, a lot of these trees are biennial or even longer bearing, meaning they make a big crop one year, and then they have a 1 or 2 or more off years, and then they make a big crop again. So the 3-year rotation was intended to go along with that resting period that butternuts needed, and then they would warm the ground, get a big crop year, and that's a way they could get into the cycle, the rhythm with the butternuts that the butternuts needed, while also really helping to spur the crop the year that they wanted the production. However, a lot of those pests and diseases are also native pests and diseases that have been damaging the species. And my guess is that that fire was also having a major impact on those pests and diseases in the years when they were going to have the big crops, so that would probably reduce the pests pressure on the trees in those crop years as well. And it's something to remember, because the Native Americans used fire all the time to manage the landscape. And a lot of the native species from this region, many of which are edible, are probably fire facilitated, if not fire dependent. And the natives would burn landscapes also when tick populations got high. Hint, hint, hint. So anyway, that's an aside, but thinking about other ways of managing and getting back to some of these older methods is probably a good idea. Greens and shoots, those plants in that image, those are violets. Violets are widespread ground cover species that are basically edible from stem to stern. The white and purple flowered species are much more delicious and tasty than the yellow flowered ones, but all of them are edible. Even the roots are edible, but why bother cleaning them? And they self-propagate quite abundantly, and they're great as a salad green, so or a salad flower. And they grow there's many different species, and there's over 450 species of violets on the planet. There's over 1,000 cultivars that are named in the Royal Botanic Gardens at Kew in England in their database of named varieties. And only a small number of those named cultivars of violets have been taste tested. I began doing that taste testing some years ago. I found a number of cultivars. They were all bred, a part of a breeding program by a British gentleman in the late 1800s, where he alone generated 77 named cultivars of violets, and the 3 of those group of his that I found tasted like a combination of vanilla and wintergreen. They were delicious. It's like candy. And I'm sure kids would even like to eat greens because they taste that way. So those cultivars are called Etane, Rebecca, Delicia, and Little David. That's 4 cultivars. Those are the ones. And Etane, E-T-A-I-N, is the one that's most prominent on the market these days. So you should be able to find that in many nurseries, and usually in the spring. Bottom right there, we have. Those are Apios americana, or groundnut tubers. Those are a native herbaceous vine in the legume family. They're nitrogen fixers. They grow in part shade. Those particular roots are cultivars that were developed by a guy at Louisiana State University, where he's getting fist-sized tubers out of them rather than peanut-sized tubers or I don't know, quarter-sized tubers. But you can find that species growing in river valleys and wet spots all over the place. It's not uncommon, and the challenge is learning how to grow them and learning how to get the big ones to grow well, and in what combination of plants to grow them in. The middle bottom there, that purple flower, is Anise hyssop. It's native to the Pacific Northwest. It's a mint family plant. It's a short-lived perennial. It lives, 2, 3, maybe 4 years in one place, and then it dies out where it was, but it tends to sow seed and pop up all over the place. Very delicious tea plant, also a great beneficial insect attractor. Anise hyssop. And then on the bottom right, we have what I call gourmet decomposers. That happens to be shiitake mushrooms. And it turns out that the vast majority of biomass created in any given year in a forest ecosystem ends up going to rot, not being eaten by herbivores. So the way to get access to those calories is with decomposers like mushrooms. So those are some of the food uses we can get from a forest garden. We also have ecosystem functions that we're trying to create in order to have a healthy forest garden. And that's 2 basic categories. On the left there, we have soil improving plants. On the right are plants that we plant to help manage the populations of other organisms. Nitrogen fixers, people in this conference probably understand nitrogen fixation well enough that I don't need to say much about that. There's a bunch of native nitrogen fixers that are quite beautiful, including Baptisia australis, which will grow in part shade. Most nitrogen fixation occurs best in full sun because it takes a lot of energy to split nitrogen gas, N2. It has 3 electron bonds between the 2 nitrogen atoms. And it's very hard to break that apart to start using the nitrogen in a chemical interaction with oxygen or whatever to make nitrate or nitrite. So it takes a lot of energy, therefore more sunlight, more nitrogen fixation. So nitrogen fixation in ecosystems tends to occur in early succession when there's a lot of sunlight, and then ecosystems will conserve nitrogen and cycle it in the system in later succession in mature forest, for example. Mineral accumulators, I put a question mark there because for 2 reasons. One is that in my book, I used to call this dynamic accumulation, and I've been on the warpath against jargon, and it took me years to realize that the phrase dynamic accumulator was like one of the worst pieces of jargon that I could think of, and I apologize for that. So I'm now using the phrase mineral accumulator, which actually means what it says. The other reason there's a question mark there is because there's not a lot of really solid data on mineral accumulation by plants. Robert Korik has his own list, which is where we got the term dynamic accumulators for the species that we wrote about in the Forest Gardens book, Eric Tonesmeyer and I. But Duke has a website now. If you just, I think it's an ethnobotany or phytochemical database, James Duke. If you Google that, you'll find his database, and you can search for specific nutrients, and his database will give you a huge list of species and what the concentration of those minerals is in the leaves or other parts of those plants, depending on the data he had available. Nettles and comfrey are, from what we know, what I know with some solidity, are some of the best mineral accumulator plants. They both have a profile that includes 6 different mineral nutrients that are valuable to other plants. And so those are 2 that I often recommend to people, even though nettles is kind of a pain, and so is comfrey, which many of you probably know, but I've tried to kill comfrey sometimes and I've not succeeded. It's even resisted cardboard sheet mulch. I've not tried plywood and concrete blocks. That might actually kill it. But anyway, ground covers in the top right there. These are plants that we grow to cover the ground, obviously to help limit the growth of weeds. One of the best ground covers that I've used in shady situations in a forest garden is Ajuga reptans, which is a mint family plant from Eurasia. A lot of people consider that invasive. I haven't seen that issue, but I am interested in using native plants. Meehan's mint, Mehania cordata, is a native analog to Ajuga reptans in terms of its size and behavior. It's not quite as vigorous or persistent, I think, as Ajuga, but I haven't had that many opportunities to play with it. But I'm talking about Meehan's mint more than Ajuga here, just to let people know that it would be a good ground cover. And mint species also are great beneficial attractants for beneficial insects, which is what the bottom right photograph is about. One of the key things we need to do these days, because of the insect apocalypse, is create habitat for beneficial insects, pollinators, predatory insects. They both need sources of nectar and sometimes pollen to fuel their search for prey, or just so they can keep going pollinating things. And there are 3 families that are the best for that: asters, umbels, and mints. So Mehania cordata is in the mint family. It has, like the asters and umbels and mints, they all have a large number of flowers on each floret. The yarrow, the white flowers in that lower picture, are an example of that. Floret is the big mass of flowers, and there are all these little flowers within that, and each one of those little flowers matures on a different day, so that one plant will provide nectar for a very long period of time, as opposed to like a daylily, which provides nectar for a day and then the flower's dead. So the asters, umbels, and mints not only provide more nectar over a longer period, but they also have small flowers that have a short throat. And most of the insects that are beneficial that we're interested in, or many of them, have a short tongue, unlike a moth or butterfly, which has a long proboscis, which can stick its tongue way down deep into a long-throated flower and get the nectar. We want short-throated flowers with the nectar within easy reach of wasp. You can see that little black wasp there on the right-hand side of that yarrow over there. That's a beneficial pollinator and probably a predator. And we want to attract as many of those as possible for as long as possible. So, all right. So then we have this whole additional set of uses and functions which involve woody plants that coppice or pollard. That means you cut them and they resprout from the roots or from high in the trunk, like the image on the right. You know, we can use that material that regrows for a whole host of things. I did a whole talk on Wednesday night about this, which will be available when the videos come out in a couple of weeks. So I encourage you to go listen to that and watch that video, because I give a lot more detail about that. But for me, this whole coppice and pollard thing is a hugely important thing for us to work on, because we have to, for our own survival and the stability of the climate, we have to transition rapidly from a hydrocarbon economy to a carbohydrate economy. This is the fundamental shift that no one's talking about that we have to do. Get away from fossil hydrocarbons and move toward recent carbohydrates. The best way to do that and still be able to have some semblance of a fiber economy is with woody material from woody plants, and coppicing and pollarding is going to be critical to that in the long run. And in order to have that long run, we got to make use and figure it out in the short run, so we can make mistakes while we can still make use of the fossil hydrocarbons to survive. So coppicing and pollarding is very important. It was done by all of our ancestors, I'm sure, in almost every culture across every continent of this world. Coppicing and pollarding were crucial to the survival and development of human civilization in every case, and we got to get back to that. So anyway, there's a long history of forest gardens in the tropics. It's been practiced in Africa, Asia, and Latin America. In Java, forest gardens have been up to 50% of village cropland since at least 1000 AD, and the verbal history goes way back beyond that. Bottom left there, we have it's actually Morocco, not the Middle East. We have dates, figs, bananas, and olives in a layered agriculture, a large-scale agroforestry system. In a desert environment, they're using a river valley where there's enough moisture to support all those plants at that density, and they're using the upper trees to shade the lower trees and getting many more crops out of it, as well as a much more pleasant working environment. And we ought to pay attention to that, for climate chaos is going to make us really need to have that environment for ourselves and our livestock. Otherwise, we're all going to be under stress and we're not going to perform very well as time goes on. In Guatemala, this image is from a food forest in Guatemala on the right there, where they had over 300 species in a quarter acre, all of them useful. And we may not be able to get to that level of diversity and productivity because we're not in the tropics yet. We don't have as much sunlight as they have in the tropics, but you know, supposedly 10 years ago, the estimate was that in 50 years, the climate of Massachusetts would be like South Carolina. It's all happening faster than we thought it would happen. So within my lifetime, I just turned 60 years old. Within my lifetime, it might be like South Carolina here. That means we can go grow guavas and palm trees here by the end of my lifetime, possibly. So we got to really start figuring out how we're going to adapt. This is Robert Hart's forest garden also. These are other images of the exterior, interior of that. As I said, it's the first modern Western temperate climate forest garden that we know of. There are other people who argue that, and they are probably right, but his is the most popularized one. On the upper right of this upper image here, you see Robert's house. Is his little house on the right-hand side of this upper image. I don't know if you can see my cursor there. There's fields on three sides of this little space right here. That is the 40 by 80 foot forest garden outside his house. He had fields on one side, fields on the other side, fields on the third side, but inside it looked like what we see in the two images below. Very foresty, very woodsy, very dense. Unfortunately, Robert didn't really know much about plants. In fact, he said to Eric and I many times while we were there for 4 days, making a map of this forest garden, I don't really know much about plants. And you can tell because many of these plants, these trees in this bottom right image are fruit trees that are young and not full-sized, and there's a full-size plum right here where my cursor is on the right-hand side of the screen, and that's a plum, that's a plum, that's a plum, there's another plum over here, there's another plum. It's insane. The guy planted things way too close together, and a lot of forest gardeners seem to think that because we're doing forest gardening, we don't need to think about plant spacing, and it's not true. Plant spacing is a critical factor in design. Make sure you space your plants appropriately, otherwise you're going to cause stress for your plants and therefore for you. But the other thing that this image shows on the bottom right is the early spring in the forest garden, where the ground covers, the spring ephemerals pop up and green up first, and then the shrubs start to leaf out, and then lastly the trees leaf out. That whole succession of green from ground to canopy is a really critical thing that we can take advantage of, and those spring ephemeral plants can come in often before you can get stuff really growing outdoors in your annual garden. So those spring ephemerals can fill a critical food gap in the spring. And also a lot of those spring ephemeral greens are tonic plants that help our bodies clean out after a winter of eating lower quality, less fresh food. And so that's a really good thing. These are the maps that Eric and I made of Robert's forest garden. The upper left there is the canopy trees in his 40 by 80 foot forest garden. You can see that there are very dense areas and very open areas in that tree canopy. If you look below that image, there's the shrub layer, and you can see not much correlation. In fact, if there is a correlation, there's more shrubs under the trees than in the openings between the trees, and that makes no sense. I don't really know much about plants. The guy made all these mistakes, but it still was an amazingly beautiful, amazingly productive forest garden. In fact, the last 3 years of Robert's life, he could barely walk, he could barely maintain the garden, and yet he still ate out of it every day of the growing season. And you can't really say that very well about most annual gardens. If you let it go, some of the weeds that come in you can eat. Other ones, you're not going to want to eat. With a forest garden, if you get the population of plants and the population of seeds in the ground to be skewed toward the species that are edible, and you've got a lot of perennials in there, if you break a leg or whatever and you can't maintain it as much, you still can get a lot of food out of your forest garden. Okay, in North Carolina, my acquaintance Charlie Headington and his partner Deb Seabrook had a very tiny lot in Greensboro, less than a mile from the city center of Greensboro. The upper left there, you can see they loved plants so much they were allowing their house to get swallowed by plants. They had a prairie between the street and the sidewalk that they fought a lot with the city about for a while. That's their driveway there. You see going to the back behind the house. Bottom left, you see their driveway coming in next to their house. That is the south wall of their house. It's about a 4 to 5 foot space between the driveway and the house. The sun beat on that wall of the house. It beat on the driveway. The heat reflected back and forth. There's a very hot side of the house, inside and out. They planted it up the way you see there. They put that trellis up at the top of the second-story bathroom window. The windows behind that trellis are the kitchen. Those rooms were uninhabitable in the summertime. They planted those trees there. The trees that you see to the right are columnar pears. There's cultivars called Warren and Magnus that are bred to remain narrow, less than 4 foot diameter. Warren and Magnus pears that he's in very humid. North Carolina has never had a mold or other issue that's related to humidity on those trees, and they stay without pruning to the size of the space he has, and they shaded that wall and made the living room inhabitable. The trellis there, when I was there in 1997, he was growing morning glories up that trellis, but they took all summer to get to the top of the second-story window, so he started growing grapes on that trellis, so that when the grapes leafed out in the spring, bammo, instant shade on that whole wall, bathroom and kitchen. Those two rooms became habitable, and they're also growing food in that 4 foot wide space. Also notice the roof runoff collection and the soaker hose coming off of that roof runoff collection so that those plants could get easily watered, and you've got a very low maintenance system that's providing food. In the back, on the right-hand side photograph, is a 50 by 90 foot space that's so dense it's very hard to take pictures of. In the foreground there, you can see a pond that is collecting runoff off the garage roof, habitat for frogs and toads and spiders and dragonflies. And those are all doing insect patrols out in the garden. They're growing some annuals. Those are zucchinis there, some tomatoes as well, but mostly perennials in the back. Kiwis, peaches, persimmons, plums, asparagus, all kinds of perennial vegetables. The place was a jungle. Now, this is a map of that we made of that garden, but the key point here is in the words above. Charlie estimated that he did 10 hours for 2 weeks in the spring and 10 hours for 2 weeks in the fall. That's 40 hours, and then an hour per week throughout the growing seasons, 68 hours a year. And he estimated he got 8 months of fruits, flowers, veggies, herbs, and beauty out of that forest garden because it was primarily perennial. And most of that hour a week was managing the annuals that he had there. So now that's anecdotal. We don't have hard data on those numbers, but that was his experience, and he loved that garden, and he made it an outdoor living room. You can see over here, if you can see see the house, then you can see the steps coming out of the house. That's the kitchen door, and there's a grapes on trellis with a table for 4 to 6 people underneath that trellis, so you can live in your forest garden. There's a hammock under these trees at the top center here. You've got a table for 2, a little cafe table in the back by the mulberry and the peach and the plums, so you can sit back there and read books. And it made the forest garden an outdoor living room. And by living in the garden, the more you live in the garden, the more the garden lives in you. The more you can harvest, the more you can eat, the more you see what's going on. You can make observations that'll help you manage it better, or realize that there's an insect problem, or say, oh, I better harvest the plums now because they're ripe, because you're living there. If you're inhabiting it, you're gonna take the best advantage of it. The squirrels and chipmunks know that those who inhabit the garden get the fruits. And the only way to keep the squirrels and chipmunks out of my garden is to inhabit it myself, or have my dog or my cat, which I did not have, inhabiting it for me. So we can have all kinds of different kinds of forest gardens. There's we're basically trying to use all stages of plant succession. In this region, if you have bare soil and you let it go for 50 years, it'll turn into woodland. That process of going from bare soil to woodland is called plant succession. Forest gardening is really about using all stages of succession from bare soil to forest and everything in between. And one of the in-between points is what we call an old field mosaic. After the bare soil, you get annual grasses and weeds, and then the perennial grasses and weeds come in, and so do the shrubs and the sun-loving trees. And as the sun-loving trees and shrubs are coming into that perennial grassy and herby space, it's called an old field mosaic, because you get a mosaic of patches of different things dominating. Shrubs here, trees there, shrubs and trees there, grasses and herbs there, grass here, herbs there, a whole different diverse set of habitats within that one space. And you can get a very high diversity of plants, and a lot of those plants are going to be very edible. Most of the fruit trees that we have developed over the last several millennia are mid-succession trees that would thrive in an old field mosaic. Most of the berries that we've cultivated and got cultivars of that are highly tasty to us are mid-succession species. So actually, calling it a forest garden is probably a misnomer, because most of the species that we've been developing over the past millennia are actually mid-succession species. So we should probably call them old field gardens or mid-succession gardens, because most of them are going to be that kind of habitat, not an actual woodland. But you can do a forest garden in existing woods. You have to be careful, because there are species that are threatened or endangered that we don't want to wipe out. So we got to really assess it carefully, keep the best, replace the rest. And then I would, if you had existing woods, I'd really focus on trying to bring back native species primarily first, because they're the ones that are going to best live together in that native forest environment. So pawpaws are edible. Those are native. Currants and gooseberries, there are native species of those. Fiddleheads Ostrich fern is a great spring edible. There's ramps, nodding wild onions, violets. Miner's lettuce is native to the Northwest. Good King Henry's not really native, but it would grow in the shade. It's not gonna, I've never seen Good King Henry spread around that much, so I wouldn't be worried about that. Sea kale could take some shade. Sweet cicely, there's a native sweet cicely, which is hard to find in the nursery trade, but that's edible. You know, lovage would grow in the shade, not a native. Sorrels, you know, there's some wildlings around that would certainly grow. Mushrooms, like I said earlier, there's a lot of native medicinals that will grow very well in the shade. Ginseng, golden seal, bloodroot, chickweed, those are all really good things that you can grow, and you can actually begin to mimic a native forest and just skew it towards the species that are most useful to us. Black cohosh, blue cohosh, all kinds. Wild ginger is a great ground cover. There's a lot of great stuff out there. Then we can have, at a larger scale and more agricultural or forestry type context or agroforestry context, when we get into coppicing, you can have standard trees for timber or nuts in the overstory at a wide spacing, and you can have your coppice underneath that's harvested on a short or medium rotation to keep the coppice crowns from interfering with the full-size tree crowns and having competition between those two layers. And then underneath that, you can have all kinds of perennial vegetables, medicinal herbs, fertility plants, mushrooms, small livestock like poultry or rabbits, wild turkey, domesticated turkey, chickens, you know, whatever you want. You can design a whole system based on that fiber agroforestry with perennial vegetables and medicinals in the understory of that. This is what a coppice with standard system looks like in the winter just after harvest, and in the summer following harvest with the coppice beginning to regrow, just to give you a little image of that. And then you can do alley cropping. In Britain, some parts of Britain are very, very windy, and they can't grow vegetables without wind protection, so they put in double rows of apples with a wide spacing between two double rows, and then you can grow leeks or vegetables down the row and have wind protection, still have a decent amount of sun, given the wide spacing between the rows of trees. You could diversify that further by making the spacing even wider. You still have the same width for vegetables, but you have a layer of shrubs on the outside of the vegetables leading up to the canopies of the trees, and then you can still get decent sun on the berry shrubs, and then the trees be a little bit higher, and then you can run chickens or sheep underneath. You can do all kinds of stuff underneath that. On the upper right, there's a guy in Washington State who had 15 acres of Turkish tree hazels with a trellis, as you see there, with hardy kiwis growing down it. And then he had all this grass, and he didn't have any livestock, so he was mowing that grass. If he had more people and more eyes and hands and feet available, you could have a very diverse, shade-tolerant understory instead of grass in there and get many more products out of that alley crop system. So you can do a lot, you know, at different scales with these kind of ideas. The bigger the scale, the simpler it has to be, but you can still go more complex than anything I've seen yet. You can also do this on a rooftop. This website here at the top has construction details about the roof and this plant list for what they're growing in Reading, England, which is, you know, a bit warmer than here, but not incomparable. I'm sure some of the species in the list wouldn't grow on a rooftop here, but they're growing full-size fruit trees and shrubs as well as herbs in a rooftop setting. And if you can imagine that bottom left image, living in a flat on a second or third story of a building and looking at a garden as opposed to a bare roof, and the psychological effect of that, much less the heat island effect where you've got vegetation that's evapotranspiring. It's going to keep the building underneath it warmer in the winter and cooler in the summertime. It's going to slow down the rainfall so you don't have as big a flood going into the storm sewers and contaminating the streets, the rivers from the street runoff. There's all kinds of advantages. And plus, when you're on a roof, there's no deer up there unless they learn how to climb the stairs. But if you have no stairs and it's all with the deers, have to learn how to push the button in the elevator to get up there. You know, and you may not even have rats up there. You might have flying rats called pigeons, but your critter problems are going to be far less on a rooftop garden. So that gives you some idea of the range of possibilities of the kinds of forest gardens you can try. But now I want to go deep into the belly of the beast. Let me just see what my time is here. I've been going for about 40 minutes. So Good. We're almost halfway. That's awesome. You know, I had this quote from Einstein posted on the wall behind my computer when I was trying to write Edible Forest Gardens, the book, the 2-volume, 1,000-page book. And ecosystems are so freaking complex. It's just ridiculous. But I didn't want to oversimplify. People wanted me to simplify more than I did, and I still get guff from people for having not made it simpler. But if we make it too simple, then we don't do justice to what the reality is that we're dealing with. So I'm going to do my best in this next chunk here to be as simple as possible, but no simpler. At its core, forest gardening is about mimicking ecosystems. Mimicry, ecologically, is the close external or functional resemblance of one species, system, or object to another. And in ecology and natural ecosystems, that often evolves as a way to gain adaptive advantages. So the best example that most people know of this is the monarch butterfly, which eats the milkweed and absorbs cardiac glycosides out of the milkweed and puts it in its own body. Cardiac glycosides are chemicals that can stop the heart of a vertebrate from beating and kill you. It also tastes very bitter. So when you're a butterfly and you are toxic to your main predators that are flying predators that can see color, it's to your advantage to have what ecologists call warning coloration. And that's a way to warn the birds that once they've eaten you once and know that you're tasty and your heart doesn't feel good, they'll remember what you look like and they won't eat you again. So once there's one insect that looks that way and has that adaptive advantage, it's to the benefit of other species to mimic the monarch. And that's where the viceroy butterfly comes from, because it looks very much like a monarch, and it's hard for a bird to tell apart when they're fluttering on the breeze. And so the viceroy doesn't get eaten as much as the monarch, as other butterflies, because it looks like a monarch, and that helps the viceroy survive. That's mimicry. 2 points. Number one, if the viceroy butterfly became more abundant than the monarch, then there would be no adaptive advantage anymore, because the birds would learn to eat that bright orange and black butterfly. So we got to make sure that our forest gardens don't end up becoming more dominant than healthy natural forests, because the healthy natural forests are our monarch, they are our models, and we need to make sure they stay healthy and they get to do their own thing. And the other thing is that, you know, the viceroy isn't exactly like a monarch. That's not imitating, it's mimicking. It's taking what it likes and leaving the rest. And that's what we need to do. So the question then becomes, what are we mimicking from natural ecosystems? Well, and this will be in the handouts, but this is not in my book. This is a new summary that I've developed in the last few years. We're mimicking 4 Ps: properties, principles, patterns, and processes. The properties are our design aims. They're the qualities of ecosystems that make them valuable. Principles are strategies that ecosystems, quote unquote, use to make those properties arise. And those principles are applied to the structures and functions of the ecosystem, and that's what makes those properties occur. So let's talk about those very briefly, and then we'll get into some more nitty-gritty. The properties are things like stability, resilience, self-maintenance, self-regulation, self-renewal, self-fertilization, production of clean air, clean water, and the increase in water storage capacity, biodiversity, and soil quality over time. I would like to have a garden that has those qualities, wouldn't you? And I can tell you, based on what's in my book, I can tell you how to design a system, at least theoretically, and I also think, you know, I have evidence that it does work. I can tell you how to design a garden that embodies all of those qualities. The principles that we're going to talk about will help you do that. The patterns and structures will help you do that. The key thing here, though, is that these qualities can only arise by the interaction between the components of the ecosystem, not from the components themselves. So stability is about how things are relating to each other. It's not necessarily something that a specific tree or a population of trees can create by themselves. So we have to understand that these are emergent properties. They only emerge when the relationships between elements are working properly. Though, how do we get those relationships to work the way we want them to? That's where the principles come in, but I'll come to that in a minute. One of the key properties that we're after is yield, okay? But we don't have good data on edible forest gardens and the kind of yields they can produce because no one has studied it yet. So we can punt and look at the ecosystem, at the science of ecology. And this is a chart from a scientific paper from back in the 60s where they're estimating how many calories of sunshine are converted to biomass every year per square meter. So thousands of calories, kilocalories per square meter per year at the bottom there. And then ecosystem types along the left-hand side. And you can see that tropical forests, swamps, and marshes attached to algae and estuaries are getting 9,000 kilocalories or 9 million calories of sunlight are converted to biomass every year per square meter. We, on a daily basis, require about 2,000 kilocalories per day to survive. So if everything in that square meter of tropical forest was edible and digestible by us, 1 square meter of tropical rainforest could supply us for 4.5 days for our nutritional needs. But of course, not all of that is edible. Most of it is lignin and cellulose that we can't digest. Temperate forest is about 2/3 of that maximum of those 3 species, of those 3 habitats on the bottom. Agricultural land is 1/3 of the maximum. Semi-arid woodland and shrubland, a little less than that. Temperate forest is our model for the region where I live. I don't know where all of you are. I know Mark Armstrong's in Ohio, I know that. Others of you are in the Northeast too. Our maximum ecosystem productivity is about 2/3 of what a tropical forest or a swamp or a marsh can produce in terms of productivity. That's kilocalories per square meter converted to biomass. Now, the thing is that agricultural land, if it's a field of rice or a field of wheat or a field of broccoli or kale, only a percentage of that biomass is edible by us. We're harvesting, maybe 2%, maybe 5% of that biomass we're harvesting as food, as yield. And that's 1/3 of that total. But so if we look at temperate forest as our model and we say, okay, we're getting twice as much biomass per square meter per year in that forest model, that means that we only have to get half as much of that yield as half as much of that biomass as yield to get an equivalent yield per acre in a forest garden. And if we're going for diverse yields, food, fuel, fiber, fodder, fertilizer, and fun, we might be able to get higher yields per acre than you do in a monoculture agriculture situation. So we have room to play there. And I think, especially when we start talking about integrating coppice and woody material coming out, we can do way better than agricultural in terms of percentage of yield out of those systems. All right, so the principles. Let me take a swig here. I know I'm going fast. You can watch the video if you're missing stuff, and if you have questions, put it in the chat and we'll get to it at the end. So the principles, as I said, are strategies that help those properties arise from the ecosystem. Principles are a human construct. We observe how natural systems work. We discern the underlying strategies that make them work the way they do, and then we articulate those strategies as a principle. Then that allows us, that articulating them in words allows us to test them and share them and test them and refine our understanding of what's actually going on. And what I have found is that the truer a principle is, the more powerfully and the more broadly it applies. So a lot of the principles of ecosystem design that I've been playing with and developing over the years, I find apply in human interrelationships, in building design, in organizational strategy, in all kinds of stuff. It's amazing how they work across different boundaries. It's not just an ecology. So these principles derived from natural systems are the core strategies of ecosystem mimicry. And we'll be talking about these principles as we get into the next section here and what the properties are that each principle tends to create in systems. Then we get to the pattern and process. So we've got the properties, the principles, the pattern, and the process. The patterns are the structures, the process is the function. So in volume 1 of my 2-volume book, Edible Forest Gardens, I talk about architecture, social structure, the anatomy of self-renewing fertility, and plant succession, which is that change of ecosystems over time from bare soil to forest. And I'm not going to obviously go into all of these today. I don't have time for that because I wrote a whole book that covers those categories. But I just want to touch on the architecture and just one key point. Oops. Well, let me get to that in a minute. But so we got the pattern and process. We're applying the principles to the patterns and processes in order to get the properties. That's the basic thing of what we're doing here on a very fundamental, almost philosophical level. And that allows us to choose our principles to get the kind of properties we want. And this is something that I think a lot of people don't realize, and it's a very critical piece of being good ecosystem designers, is to understand what those words say right there. All right, so architecture. There are 5 elements of architecture. I won't go into each of those in detail, but when I'm designing a forest garden in terms of architecture, the basic process I use is to look at the whole area. This is about 6/10 of an acre at Wellesley College. And the first thing we did was say, okay, what are the different habitat bubbles? We have a nut grove, we have a fruit woodland, we have an eddo or edible meadow, we have a coastal sandplain mimic, we have a fruit thicket, a meadow oak classroom, and a stable shrub thicket. And each one of those habitats has a different architecture in terms of the layers of vegetation, the density of vegetation in each layer, the patterning of the vegetation, and the diversity of plants and animals that are in them. And we can define those specific things about the architecture for each one of those habitat types. And then, so if you look at the fruit woodland there, and you look at that close up and turn it sideways, within that habitat, there are patches. And there were, I forget how many patches, there's like 16 different patches within that one habitat. A fruit woodland is fruit trees widely spaced, so there's space between the fruit trees for sun to get to the ground. And so in that area, we have these orange and blue dotted patches are experimental spaces where the round circles are experimental plots with ground covers around them. The yellow spaces are nectar and nitrogen patches, and those are clustered between the fruit trees so that the nitrogen can get to all the roots of all the fruit trees, and the nectar is attracting all the beneficials so that the beneficials will be next to all the fruit trees. And we also have the nectar away from the main pathways where the people are, and the green patches are the perennial vegetable patches that are close to where the people are, so you can harvest the perennial vegetables as you walk by, and people can see them and take care of them better. And so each one of those patches has a different cluster of plants. They don't have to, but they do in this case. And so there's a lot of diversity of species in there, but there's a pattern to the patches. There's an architecture to the patches, and then you can design each patch to have a certain architecture. And this is actually not in the fruit woodland, but this is nearby. And we have chosen every species that you see in this for specific reasons: for mineral accumulation, for ground cover, and for attracting beneficial insects, as well as for crops. So that's the basic pattern. I designed from pattern to details, pattern to details, habitat pattern to patch patch. And that simplifies things greatly. It helps you make good strategic decisions before you start getting into tactical decisions, because the mistakes at strategic level are the ones that usually cost you the most for the longest period, and they're the hardest ones to change. So design it in pattern form first, and then go into the details. So that's a quick thing on architecture. The other thing I want to say about architecture is that the architecture is our primary tool. When you're managing, when you're planting, when you're harvesting, when you're weeding, you are directly interacting with and affecting the architecture of the ecosystem. but it's through the design and management of the architecture that we have, the only leverage that we have to try and influence the social structure of the ecosystem, how species interact with each other, how nutrients move, and how succession is happening in that space. So the architecture is our leverage point, and we're trying to use that as a way to get to the social structure, the self-renewing fertility, and the succession. Now, I've given you what I'm going to tell you about architecture for tonight. I want to focus on the social structure. And I'm not even going to talk about all those different pieces, because this is really very core to a lot of ideas around ecosystem design, as well as to the design of human social structure. And there's a lot of analogies that we can make that I won't make today, but I'm just seeding these ideas in, because if we don't figure out how to design good social structure in our forest gardens, they won't work very well. And so it's really essential that you get the principles here. And then if you think about it in terms of human social structure, you'll see the analogies I'm trying to make. And I think it will help us design better social structures for ourselves that we need to do if we're going to actually be able to run forest gardens successfully. So our models, our natural ecosystem models, have a very high species richness. In healthy, temperate, deciduous forests, the tree canopy had 10 to 18 tree species in 1/10 of a hectare. 1/10 of a hectare is about 1/4 acre or 100 by 100 feet. 10 to 18 trees in 100 by 100. That's a high density of trees, a high richness of tree species in a small space. Shrub layer, similar, 10 species in 1/10 of a hectare, 100 by 100 feet. Herb layer, 14 herb species per square yard. How many of you know a natural forest with that much richness in the herb layer? I would ask you to raise your hands, but I wouldn't be able to see you. I doubt, every time I've asked that question with a crowd of 50 or 100 people, usually 1 or 2 people raise their hand. What that means is, if that's true, is that if you have not seen that, you have only ever seen a damaged ecosystem. You didn't have no idea what a healthy, temperate, deciduous forest looks like. And that's very sad. And it also means that we have to envision our model, because we don't actually know our model. If you live in the Northeast, there's a book, Mary Bird Davis wrote a booklet on old growth in the East. And there are, in every state east of the Mississippi, there are patches of old growth that you can go find, and you can go see places where the density of species in the herb layer is that high. And I will tell you, it is a very different feeling, and it's mind-blowing what it is. That image in the upper right is about a square foot of old growth forests from the Berkshires, and there are 9 herbaceous species in 1 square foot there. 35 to 40 species per habitat in the herb layer in healthy, temperate, deciduous forest. Now, if we're going to mimic that level of richness in systems that we design, especially with species that are from all over the world, because they're things that we want to eat or we want to use for medicine, then we have to learn how to pack plants together into patches with minimal competitive exclusion. And that is going to take a lot of understanding of these plants in order to do that. So what I want to do is help us learn, give you some what do you call them? Trailheads into how to do that. And this quote is actually fundamental to that. And David Perry, author of Forest Ecosystems, said, "Ecological communities are not as tightly linked as organisms, but neither are they simply collections of individuals. Rather, the community is a unique form of biological system in which the individuality of the parts acts paradoxically to bind the system together." That first sentence is summarizes 150 years of argument in the science of ecology. Some people arguing that, that an ecosystem is like an organism, and that one species is like the lungs, and one is like the heart, and one is like the stomach. And if you remove one species, the system will fall apart because it can't function right. And that's not really true. There's some truth to it, but it's not really true. But the people who argued against that idea were that there was no interaction between species, and there was just the overlapping of ranges that caused the plant communities that we see out there. And they're not true either, even though there's some truth in what they're saying. But the reality is that we have this unique biological system in which the differences, the individuality of the parts is what helps them bind together. And that I want you to deeply understand that. And hopefully by the end of this talk, you will understand exactly what that means and how to make that happen. We start with an individual species and what its niche is. A species niche is all the inherent functions and characteristics of a species, all of its interactions between itself and its environment. What are its context, what are its predators, what are its allies, its needs, tolerances, and preferences, its characteristics, its products, its functions, behaviors, its core strategy. There's a lot of details in there. This image will be in the handouts, by the way. And every species is different. And the more we understand all the details of that, the better we're going to be able to design for a given species so that it's not under stress. We can do a species niche analysis of plants, and we can also do it of ourselves. And in fact, I recommend that we do, because if we understand how we interact with our environment, what we yield and what we need, it helps us design habitats for ourselves better and realize that we're not these isolated individual things that are separate from everything else. All right, so this idea of species niche is an embodiment of the principle of multiple functions. The observation that everything interacts in multiple ways with its environment is the source of the reality of the principle of multiple functions, which is that every design element of a design should perform at least 2 useful functions, ideally 3 or more, because everything does have multiple functions. Everything does interact in multiple ways with its environment. The better we understand it, the better we can make use of that. The more functions we'll get out of something, and the more bang for the buck, to use a military terminology, an atomic and nuclear phrase. So we want every element to perform at least 2, ideally 3 or more useful functions in our designs. The other principle related to this is the principle of stress and harmony. Stress can be defined as not being allowed to perform natural functions, forcing functions that are unnatural, and having unmet essential needs. Harmony is the opposite. All your natural functions are permitted, no functions are forced on you that you don't want, and all your needs are met. Think about the worst job you've ever had. Put it in the context of stress that I've defined there. Think about the best job you've had. Think about that in terms of harmony and your needs getting met. Those questions can help you identify your own species niche. And you know, the plant, obviously the privet pruned into elephant shape is under some degree of stress. But if you tried to prune a hazelnut or a blueberry into that shape, it would be even in more stress than a privet is, right? The plant at the bottom is just being its beautiful self, and the harmony of that form and that function is quite gorgeous to perceive, even though some people consider that an invasive species. So those are 2 of the principles. And when you put those 2 principles together, you realize that you can design, if you understand the species niche and the multiple functions of a species, you can design a system where harmony is greater in the system for any individual species, but you're still getting yield from it. And we're not putting the system or the species under stress by forcing it to pump out tomatoes or forcing it to pump out peaches or pears or apples. And forcing it, we can allow and provide harmony. So that's what we're trying to do there. So then, a complement to the species niche is the community niche, which is basically the same information as in that diagram of the European pear earlier, but looking at it in terms of what role does it play in the community. So there's that butcher, baker, candlestick maker idea. Well, you could have a nut tree canopy herbivore, and a nut tree canopy predator. That's like the butcher, the baker, and the candlestick maker. And if you plant a nut tree, you're going to have canopy herbivores. So if you're going to have canopy herbivores, you want to make sure that there's habitat for canopy predators. Otherwise, the task of being a canopy predator is going to fall to you. Do you want to be a canopy predator? Is that part of your niche? Do you want to crawl around in the canopy on twigs and look between the twigs and the leaves and the underside of leaves looking for predators and eat them? Probably not. But if you're out there spraying, you're basically doing that job. And I think it's possible, if we get smart about it, that we can design ourselves out of that job, and yet we can still be harvesting. That's the idea. So a community niche is basically a community function. Now, there's a principle that I have derived from all this, that a community's viability and vitality depend upon the performance of critical functional roles. That's pretty obvious. The more functional roles performed, the more vital the community. For example, every ecosystem has to have producers making energy, making biomass out of sunlight. Every ecosystem needs decomposers. Without one or both of those, you won't have a functional ecosystem. And you can expand from there. And obviously some functions are more critical than others. But, and there's many different functions that we could be talking about. There are 4 initial ones that I focus on teaching people and trying to get us good at in forest garden design. That's crops. Obviously, we want crop guilds, crop plants, and we want to think of the season of the kind of crops, what our nutritional needs are, and the site conditions. Ground covers to help control succession and plant behavior. So we need to have runners, clumpers, and mat formers to have a good polyculture of ground covers. We need to think about their density, their height, their rate of growth, the site conditions they tolerate, and whether they're foot tolerant or not. Then we've got the soil improvers. What nutrients do they gather? How deeply rooted are they? What kind of site conditions will they tolerate? And then the 4th one is generalist and specialist nectar plants for insects. So a generalist, in my terminology, those are the pollinators. The specialists are the predators and parasitoids. And we want to make sure we have a lot of pollination pollinators around. So because lack of pollination often limits fruit production. How do you do that? Well, you got to make sure there's pollen and nectar around year round. If there's only nectar around for part of the year, the population will grow and then crash, and there's nothing around for later on. So you might need to make a chart like this and say, okay, you've got April, May, June, July, August, September, October across the top of the chart. And you say, here are the species that are flowering in those different months according to the books. And you try to have more than one species flowering in each month, because who knows if they'll flower in the early or the late part. And you're trying to have redundancy in that. And then you get things flowering throughout the whole growing season. And you're more likely to ensure that you have the insects around that you need. We can design that. We have the ability to design those kinds of plant systems. That is the principle of redundancy principle, that we want to meet every essential need with more than one element. When you're looking at that nut tree canopy herbivore situation, you can have a tree frog, a bird, an insect, or a bacteria, or a fungus. That ant there has fungi growing out of it that killed the ant. So you can have a fungus, a bacterium, a tree frog, a bird, or you controlling those canopy predators. You want to have more than one species meeting the need of canopy herbivore control. Otherwise, if the conditions aren't right for the tree frog, it's too dry a year, you may not have tree frogs up there and you won't have herbivore control. So you got to have a bunch of different species that can tolerate different things going on in there. So, community functions are essentially the same as community niches. The community niches, here's a bunch of species that fill different niches, focusing on crops. Persimmons are an amazing crop plant. They're quite prolific and productive. They're not very wind tolerant. They're not very ice tolerant, but they're amazingly productive and very tasty as long as you eat them after they're fully ripe. They grow in crappy soil. They're tap rooted. They will sucker, but they're very nutritious as well. Then you've got hazels and filberts. Again, very nutritious. They're like soy in terms of their protein and oil content. Some cultivars are up to 60% oil content. They tend to be flat rooted. They can be tap rooted. They're multi-stemmed. They can deal with some deer pressure. They create thickets. Squirrels are your biggest challenge with them. They're very hardy. I highly recommend people grow them. There's a lot of great cultivars out there now that are eastern filbert blight resistant. Hardy kiwi, amazing fruit. 10 times the vitamin C of lemons, supposedly. You can store them for up to 6 months in a box or bucket in a root cellar. They are also medicinal. There's a lot of Chinese medicinal uses for those. They have very minimal pest problems. Some people consider them invasive. They're illegal in Massachusetts, but I plant them anyway. because I think it wouldn't be bad to have a high vitamin C crop growing wild throughout the Northeast that would replace all the citrus we get from Chile and California and Florida and Texas at high hydrocarbon cost. Sea kale is a herbaceous crop. It's native to the coastal dunes of Europe, growing on very crappy shingle soils and sandy areas. It's tap-rooted, long-lived, has edible shoots, edible leaves, edible broccoli, and the creamy white flowers are incredibly fragrant, and it just spreads a very strong honey scent for many feet in the garden. It's a very delightful plant to have around, and I have not had any issues with pests on this species in my garden. It's a really good plant. Ramps are an amazing native edible, probably the best tasting native edible, in my opinion, that are around. They like rich, moist woods. They're a spring ephemeral. They come out for about a month in the very early spring before the trees leaf out. They carpet the ground, then they disappear. They're a tonic herb. They're likely to be very high nutrition. I haven't actually done any research on their nutritional value, but my guess is that they are a good spring tonic plant. And they may, because of the way they grow, they may be what's called a vernal dam of nutrients, that because they're so early spring growing and they grow in such abundance, they may take up a lot of nutrients that are highly available in the soil and lock it into their bodies at a high rainfall and runoff time of year and stop those nutrients from leaching out of the watershed en masse. There are studies on yellow trout lily being vastly important in that regard. So any spring ephemeral that is a kind of a mass spring ephemeral may be playing that kind of role in the ecosystem. Then we have the shiitakes. This guy on the bottom right here, he had an 800 square foot backyard with shade cloth, and 800 shiitake logs in his backyard. In an urban backyard, he was making $10,000 a year selling shiitake to restaurants in his city in Ann Arbor, Michigan. So you can make a lot of money in a small space, and that doesn't have to be shade cloth. It can just be trees. Ground covers, things like prostrate bird's foot trefoil is a great nitrogen fixer, only an inch high, very dense, trample tolerant, zone 5. Doesn't do well in drought, unfortunately, but it's a great path plant. I really like it a lot. Green and gold is a native plant for beneficial insects. It's an aster family, semi-evergreen, really likes moist soil, sun to part shade, and zone 5 hardy. Those are just two of many, many different ground covers that can be grown to get a low ground cover that then you can have your emergent perennials coming out of and have good access to your fruit trees. Nitrogen fixers, I talked about Wablue indigo earlier. It's just a great, beautiful species. Lupins, there's Thermopsis caroliniana. There's a fair number of native nitrogen fixers, not as many as you might think. There's a lot more nitrogen fixers native to Eurasia for some reason. In the plant lottery, Eurasia got a lot more nitrogen fixers than we did over here. So for a lot of reasons, you kind of got to end up, in some cases at least, going to the non-native nitrogen fixers to get your needs met. Dutch white clover is a fantastic ground cover, low ground cover, path plant, nitrogen fixer for forest gardens. I use quite a bit. So then you've got mineral accumulators. This one happens to also be a crop, but French sorrel accumulates phosphorus, potassium, calcium, iron, and should you need more in your diet, sodium. But it's very sour edible green, will take part shade, quite hardy. There is a cultivar called Profusion that never flowers. So you can get a lot more leafy greens off it throughout the growing season. Doesn't do well in super hot, dry, sunny places, but it's a great crop. Then you've got mountain mints, which is a nectar plant. Mountain mints are one of my favorite plants. There's a bunch of native species. The taxonomy is a little confusing, but the range and diversity of pollinators and other insects that come to this plant is just phenomenal. Some really trippy wasps I've seen on these pycnanthums, and they're pretty good tea plants as well. But I just love having around, and some of them will be self-sowing and just really gorgeous plants and great cut flowers also. Comfrey is a great plant for not just mineral accumulation as it shows at the bottom there, and I missed my jargon, my war against jargon. I'm losing on that slide there, but again, potassium, phosphorus, calcium, copper, iron, and magnesium are concentrated by this species, but it's also great habitat. For some reason, lacewings love to lay their eggs on it. Parasitic wasps and spiders tend to hang out on the plant. Spiders overwinter in huge numbers. 250 spiders per square meter in the soil under comfrey overwinter. And it's probably because of those minerals. If you can imagine wanting to overwinter, if you're a soft-bodied arachnid, the place you'd want to overwinter is where you could passively absorb nutrients all winter long and help keep you healthy while you're sleeping. Maybe we should invent beds that do that. Anyway, so a community niche is a community function. A group of species that are in the same community niche are serving a similar community function. That leads us to the idea of a guild of species that are performing the same community niche, same community function. You could call that a community function guild. The word guild back in the medieval era was defined by what the community function of the weavers or the barrel makers or the wheelwrights or whatever. They had guilds in the medieval era. That's where this ecological science word guild came from. But it turns out the word guild was misused by the ecologists because some were using the word guild to mean one thing and others were meaning it to use several other things. And they were getting into arguments about what guilds were without realizing they were talking about different dynamics in an ecosystem. So I started coining these terms that put adjectives in front of the word guild to be clear about what I'm talking about. So the first of the three meanings that I've so far figured out is community function guild. This is a set of species in the same community niche that are serving a similar community function. So you've got, here we have three different tree fruits in a tree fruit guild. You could have a berry fruit guild. We have two species in the stone fruit guild, but only one pome fruit, so no guild, because there's only one species. All right, so you can define a community function guild pretty much any way you want. There's really no limit to how you can define it. It really depends on your purposes. But crops is one of those functions. Ground covers is another one. Soil improvers is another one. Beneficial insect plants is another one, and you can define each of those in more and more detail, right? The second kind of guild is what I call a resource partitioning guild. It's a group of species that partition scarce resources to avoid competition. The key point here is that competition can only occur when you have two or more individuals that need the same resource at the same time in the same place, and the resource is scarce. In this diagram of the root systems of prairie plants, they found in the 19-teens that about 50% of prairie plants had their main absorbing roots 5 to 7 feet below the ground, 25% 2 to 5 feet, 25% 0 to 2 feet. They were partitioning water in the soil to avoid competition. The plants with the deepest roots were green all year. The plants with the shallowest roots went dormant in the dry summertime. That's a resource partitioning guild. When you have a resource partitioning guild, it reduces competition, it allows greater diversity, it increases productivity. Those are some of the properties that we'd like to have in our garden. So if you use the polyculture partitioning principle, by partitioning resources, you will get those qualities arising in your forest garden. You can do this with woodies. In the back of volume 2 of my book, we detail for as many of the 600 species in the back of the book what we know about the root patterns of those species. Taproot plants, heart-rooted plants, flat-rooted plants. You can imagine if all your trees are flat-rooted, that you're going to maximize competition. But if you mix up tap, heart, and flat-rooted trees in your forest garden, you'll reduce competition among those trees because their roots are going to be in different parts of the soil profile. It's pretty obvious what we're talking about there. Chestnuts are tap-rooted. They're also sun-loving canopy trees in the ones that we used to have growing around here. Juneberry or serviceberry grows underneath chestnuts, and all the serviceberries I have information for are flat-rooted. They're also shade-tolerant. They're partitioning the soil and they're partitioning the light. That's one reason they grow well together. That's a resource partitioning guild right there in two respects, both light and soil. That's two resource partitioning guilds with two species. Then we have the mutual support guild. The best example I have of this is in California, where they grow grapes. And in some places they have issues with this pest that is called the grape leaf hopper, which eats the leaves of the grapes when it's a larva like this, and that reduces the photosynthetic area, and the grape yield can go down if you have too many of them. Not all the vineyards had this insect in large numbers. Some did. They tried to figure out why. It turns out there's a wasp that parasitizes the larva of the grape leafhopper called Anagrus epus, and this wasp in some vineyards was at high population, but not others. Why was that? Well, it turns out that raspberries have a leafhopper also, and the wasp will, and the raspberries leaf out before the grapes do in the growing season. The raspberry leafhoppers appear earlier, and the wasp increases its population on the raspberry leafhoppers so that it has enough wasps around to control the population of grape leafhoppers. So that is the raspberry, the wasp, and the raspberry leafhoppers are supporting the grape. And probably because the wasp is keeping its population high on the grape leafhopper, and then it probably moves to a different leafhopper throughout the growing season, it helps keep the population of wasps high throughout the whole growing season, so there's enough to overwinter so that they can control the raspberry leafhoppers the next spring. So what goes around comes around. That's what I call a mutual support guild. This is the principle of functional interconnection, that you want to locate elements so the inherent yields of one meet the needs of other elements. So what that does is creates a web of mutual support. It builds stability and harmony in the system, and it reduces stress, work, waste, and pollution. Those are, again, things that we would like, properties that we would like to have in our forest garden. So if you apply this principle with a mutual support guild, you're going to get a more stable, more harmonious, less work, waste, and pollution kind of forest garden by having a resource partitioning guild. Here's the kicker. This mutual support guild of grapes, raspberries, wasps, and leafhoppers can function when the grapes and the raspberries are as far as 4 miles away from each other. They're not a polyculture. They're not growing in the same patch. They're a guild. They're still in relationship, but they're not growing together. So a guild is not the same as a polyculture. Not all guilds are polycultures, but to be effective, a polyculture must contain guilds. A polyculture is, as I said earlier, when you have more than one species growing in a patch. A patch is a very small area of ground, all right? If you just randomly put plants into a patch together, some are going to outcompete others, some might grow well together, you don't really know. But if we design our polyculture so they contain the guilds that I just talked about, we're going to be more effective at having a polyculture that works. So a polyculture is defined by who grows in the same patch, whereas the guilds are defined by the relationships between the species. We have the community function guild. That's a shared function, a shared niche. It's the principle of redundancy principle. You can have more than one species performing that function. A resource partitioning guild is where you partition a shared scarce resource to avoid competition. That's the principle of competition and the polyculture partitioning principle. Mutual support guilds where the needs of one element are met by the needs of another, yields of another. That's the principle of functional interconnection. These three guilds are critical to work into the design of a polyculture. Let's look at this well-known polyculture of the three sisters: dry corn, dry beans, winter squash. It's one polyculture, it's 3 species, but I've discovered at least 13 guilds in this one polyculture of 3 species, because you have all different ways the plants are related to each other in terms of rooting space and sunlight and insects and pollination, and the beans climb on the corn, and the corn and the beans shade the squash, and the squash does weed control for the corn and the beans, et cetera, et cetera, et cetera. There's 13 different guilds in one polyculture of 3 species, and that's why when you convert the 3 sisters to an industrial scale system, you get 17% more calories out of the same area when you grow those 3 crops as a polyculture as opposed to as 3 monocultures. 17% more calories per acre. That's this, you know, if you figure that that's 6 months worth of food, it's dry corn, dry beans, and squash. 17% of 6 months is weeks of food that you're getting extra just from having a polyculture if you're doing a subsistence agriculture. For the Native Americans, that was no small deal at all. It meant the difference between starvation in late spring and not starving in late spring. Or early spring, late winter. So what can we do? We can use that Three Sisters as a model and use the Jerusalem artichoke, a big tall crop plant that makes very nutritious edible tubers, and use that as a corn analog. We can use that Apios americana, the groundnut I talked about earlier, as the bean analog. You can see its leaves right in the center of that middle image, and this pinkish purple flowers underneath. And then we were using initially, we tried this for the squash analog, we were using a plant called Chinese artichoke or mint root, which has an edible tuber, a mint flavored edible tuber as the squash analog as a ground cover in between. And we can make analogies between the native, let's call it the native ecosystem of the Three Sisters, and we can start playing with perennials and plug them in to mimic that polyculture of Three Sisters, and it works fairly well. The mint root or Chinese artichoke needs more sun than it gets. The Jerusalem artichoke has big wide leaves. Corn has narrow leaves. That means the groundnuts gets more shade. So now I'm trying to find narrow leaf sunchoke cultivars, so we can have something more like corn and more sunshine for the plants growing below the sunchoke, including the groundnut. But the groundnut has a very nutritious tuber. It's more nutritious than potatoes. You can use it like potatoes in many respects, but it takes longer to grow. It takes 2 seasons to get to an appreciable size, and typically, at least in my experience, but you can get a lot of production out of these, the Jerusalem artichokes, the sunchokes. So that's one analogy. We didn't find the mint root to be very effective there. It was kind of an additional little minty thing here and there when you're harvesting, but you can also, we can make it 2 stitches and substitute for another native plant called hog peanut or ground bean, Amphicarpia bracteata, much more shade tolerant than the groundnut. But the problem is that the beans, the little beans that it makes in the ground are the color of soil. They're hard to find, but the Native Americans, it turns out, would let the mice gather the ground beans, and then they'd trade corn for the ground beans from the mice, and that's how they collected the ground beans, apparently. But you know, we can start making these kinds of analogies, not just with the Three Sisters, but with our native ecosystems, right? And we can start playing those kind of games. So I want to look back at this and realize that this idea of the individuality of the parts binds the system together is critical here. The fact that corn and beans and squash are so different from each other is what helps them be able to interact in a way that binds them together into a system that is greater than the sum of the parts, and you get 17% more calories per acre in a polyculture than you do growing them separately. That's what that individuality, bonding them together, means. It means that you've got guilds in your polyculture and the interactions are being mutually supportive there. And that's what we need to learn how to do in our forest gardens with a whole diverse array of species that we have available right now from all over the world that are useful and beneficial to us and can be useful and beneficial to our ecosystems. So what that gets us back to is this idea that we have to cultivate and perfect ourselves, that we have to change the way we see, the way we think, the way we design our agriculture as an ecosystem in order to farm and garden in a way that's more ecological. And the question I want to leave you with is, who do we have to be to design and effectively interact with that kind of ecosystem? Thank you.
Thank you. Thank you so much, Dave. As we are just at 6:30, I thought we could spend 10 minutes if you're into hanging out for a couple of minutes to answer some questions. How's that sound?
Awesome, after I wet my whistle.
All right. Well, I'll start from the beginning. There's a couple specific questions. In particular, the variety name again of that Apios americana that you mentioned. That
well, the guy at Louisiana State, he created 42 cultivars, and only a few people have them. One of the nurseries that carries them is Oikos Tree Crops, Oikos. They're online. They're out in Michigan. Green Light Plants, I believe it's Dale Hendricks, HENDRICKS, Green Light Plants in Pennsylvania. He carries a bunch of those cultivars. I think those are the two main ones that I know of that carry those cultivars, but they've named them different things. The cultivars only had numbers from the guy from LSU, and then he retired, and he's parceled them out to a few different places that are now selling them under whatever name they gave them. So that was one specific question.
And will the groundnuts tolerate, dry, sandy soil?
Not that well, unfortunately. I've tried them in my dry, sandy soil here, and they don't do well. They really need a good amount of water. It seems like I've seen them growing on the edge of a road going through deep forest in a wet situation, and I was surprised that they would grow in that wet. The place where I've seen them most often is in the sandy floodplains of streams up in Conway, Mass, and places like that, where it's it's dry, but there's moisture underneath because the water table is close to the surface by the stream. Sandy's good because it helps the tubers grow, but the moisture is necessary. Is my take.
Yeah.
Maybe under a downspout or something,
Right. And another question: do you have any good sources for native nettle seed?
Boy, I don't. But the place for hard to find seed, the place I typically go to is B&T World Seeds. They're in, I believe, in the Netherlands. They have an incredible number of different seeds from all over the world. They probably have that in there. But I'm sure with a Google search you can find that kind of stuff. But native nettle is one that I've not been able to find myself, and I haven't gone looking for the seed because I'm still trying to get my systems set up here, and not, I've got a lot of plants, but not as many as I want. So.
And then there's a nice question about the edible ecosystem garden at Wellesley College. How do you think it's currently doing, and compared to how you planned it to do? And would there be any things that you would like to do differently or change?
Oh God, how much time do we have? I mean, we started planting that in 2011, and we spent 7 years getting it installed. And I haven't been there for a couple of years. Last I looked, it was doing pretty well. There's some strategic errors that were made early on in the implementation that were beyond my control that really set it back in terms of some of the weed. It's really important that you get your weed populations where you want before you start to plant. It's really worth taking a year or 2 years, even 3 years. Like they had crown vetch. It's a really challenging species to kill. It's got very vigorous rhizomes. It'll grow up to 2 or 3 feet high and smother things and kill things that are shorter than 2 to 3 feet high. And it's just really hard to kill. So we really want to try and wipe that out because there's a solid stand of it right in the core of where we put that forest garden. And the guy who implemented our very specific detailed instructions didn't listen to our specific detailed instructions for how to kill it. And it escaped and got back into the garden, and it is
frozen. Let's see if the connection comes back.
I do really feel good about the pattern I showed you with the designing from habitat to patches. Am I freezing up? Did you follow all that?
Yeah, your connection is a little bit choppy.
Okay, well, the pattern of designing habitat patches, then designing each habitat patch, each habitat into patches, and then going in patch by patch and designing it, I highly recommend. And it really simplified the brain overload process. I think I don't know. I mean, there's a lot that went well there, but I having not seen it for 2 years, it's hard for me to speak for what's going on. I know that it's a very hot, dry, sandy site, and the mints love it there, and the mints are fairly aggressive, and so they're ending up battling with species that we planted. And if it were my garden, I would probably not do as much battling with the plants, the species we planted, and just try and let it ride a little bit. But they have specific educational objectives, and so it's a whole different story than if it were my garden. So
here's a great question from Lenore. How easily would it be for homeowners and gardeners with guidance to be able to transform a lawn to a forest garden on their property?
That is the absolute right thing to do. That's the easiest way to get a forest garden and have very few weed problems, depending on what your lawn is like. It's quite easy. I use cardboard quite a bit for that kind of process to kill the grass, because grass can be a pretty strong competitor. But you can plant. My strategy typically in a grassland situation is that I will plant the woody plants in the pattern I want, and then I'll sheet mulch it with cardboard, and then I'll put coconut fiber, erosion control fabric over it, or some sort of a fabric over it. Even I'm blanking on, they make bags out of burlap. You can use burlap. That allows the sun and the moisture. It allows the sun and the air to get to the cardboard, so the cardboard doesn't break down too rapidly. And you leave it that way I've had that last for 3 to 4 years. And that gives you more time to get your perennials. The perennials are actually way more expensive than the woodies. The woodies are fairly cheap, especially if you buy bare root and you plant small plants. It's much cheaper. The ground covers are more expensive. So if you start buying flats of ground covers and get them established in one area, then as the cardboard is breaking down, you can start propagating from the areas that get established into the cardboard that's breaking down. And it's a slower way, but it's a very effective way to transform a lawn rapidly into an edible and diverse ecosystem. And I highly recommend it. The world needs a lot less lawn than it has.
I agree with that too. Great. I think we're gonna wrap it up here. So thank you so much, Dave, for all that great info and insight. Thank you so much for attending the NOFA Summer Conference, and we look forward to seeing you the next time.
Take care. Thank you, Doug, for hosting.
Thank you, Dave.
Enjoy, everybody. Much love, and stay healthy.